Hello and welcome everyone. Can you guys let me know in the comments if I'm audible or not? Let me know if you guys can hear me. See, two people joined the session. Can you guys let me know if you guys can hear me on Facebook? Do write comments and let me know, please. Thank you, Adib and Himel. So, hello everyone, welcome to TensorFlow User Group Bangladesh. It's me, your host, Jainul Abidin Mia, a third-year computer science student of BRAC University and also a co-organizer of TensorFlow User Group Bangladesh. And I'm really excited to kick off our first ever session of Machine Learning Reading Club. Thank you, Ananda, for your comment. And so what's Machine Learning Reading Club is all about? So basically, it's a platform where all the students, researchers, gather around their interest on latest machine learning advancements through research paper, lens of research paper. And today we're gonna read a research paper. So what's the research paper we're gonna read with? So basically we're gonna read a latest research paper which was published on prestigious journal Multimedia Tools and Application MTAP. So which is video analytic for activity profiling at false and unstable motion detection. This paper presents a video where it detects unstable motion activity and fall. So this application helps elderly people and lots of applications. So this paper was published by none other than our university assistant professor, Dr. Aniqua Zereen ma'am. So we're glad to have her here with us in this session. So before I welcome her for introduction, I would like all of you to ask questions. So to make this session more interactive, your questions would make mean to us a lot. So sorry. Thank you. So let's give a warm welcome to our ma'am, Dr. Aniqua Nusrat Zereen ma'am. Hello, ma'am.
Hello, Zainul. Thank you very much for the platform. Hello,
Yes, we're glad to have you here.
hello, everybody. A short this introduction of mine is I'm currently working as an assistant professor in BRAC University in CSE department, and I am also working in the area of artificial intelligence and machine learning for the undergraduate and postgraduate students. So today, the invitation from Zainul was very exciting, and this is my first ever session. This is my first ever session on coming online and live in front of many students and colleagues. So I'm really excited to share my PhD journey and the dissertation that I have done. The paper that was published back in 2023. So I will be actually sharing a video, pre-recorded video that will go through in-depth knowledge of the paper. So all the information are stored inside the video. So if you have any
Yeah,
questions,
we're excited.
yeah, if you have any question, please let me know in the comment section, and I'll be here to answer all of your uh, all of your questions. And also, I will be really appreciating if you have more ideas to collaborate and do research on this field, because this is really a social work that can help elderly people, not even only elderly people, maybe some other people sectors that can help with this
Yes.
kind of technology. Yeah. Thank you, Zainal.
Yeah, let's play the video. Share my screen. Do let me know in the comments if you guys can see the video or not.
My dissertation topic is video analytics for elderly fall and unstable movement detection on an embedded device. Real-time detection of falls and unstable movement by elderly people is vital to their quality of life and safety. Current research and development in video processing for elder care focuses on detecting falls and detecting and recording elderly people's activity over time. Opportunities for more proactive monitoring of elders' activity patterns have not been explored. Real-time unusual behavior alerts may help prevent accidents rather than speeding up an action after the fact. We present an age processing device integrated with a cloud computation framework that can be used for activity profiling as well as trigger alerts for falls and unstable motion by elderly people at home. The objectives are build a prototype IoT video monitoring device for elder care, design and implement techniques for activity profiling and fall and unstable movement detection based on pose over time, and perform a series of experiments in which the devices and system are used in elderly people's home for a period of time to evaluate the efficacy and usability of the system. To achieve the main objectives, the scope of the dissertation entailed the following main activities: design and implement a prototype IoT video monitoring device, implement basic human detection, tracking, and recognition modules, implement basic fall detection and activity summarization modules, design and implement a framework for cloud storage and analysis of human behavior data, research early indicators of unstable movement that could lead to falls and other actions, design and implement a module for early warnings about unstable movement, and evaluate the system in a realistic scenario. Limitations: the most significant risk is that users' privacy may be compromised by 24 hours video monitoring. The research must take extreme care to ensure that no personal data about user is released by conducting the experiments. In the system, fixed cameras are used to capture video frames of each visible person. Each individual is tracked and their action over time are classified into 9 ordinary activities, falls, and unstable movement. We consider unstable movement to include the moment before or after a fall that could be due to physical collapse, chest pains, an accidental sleep, tripping over an obstacle, or a sudden fit of dizziness. When the system detects a fall or unstable movement, it sends an alert. The system is built using an embedded edge processing device, the NVIDIA Jetson TX2, connected to a cloud-based infrastructure for storage and analysis functionality. People detection, tracking, and skeleton extractions are performed by edge modules. The cloud service performs face verification, activity classification, and unstable movement. The two classifiers run in parallel on the cloud service. When a fall or an unstable action sequence is detected, an alert is sent via a RESTful web service. To enhance safety further, the system also sends an alert when the person is absent for an extended period of time. Normal activities are used to generate a summarized action profile for each individual. There are 5 different types of datasets. Number 1, the movie online dataset consists of 90 people. Number 2, AIT Artificial Intelligence Center's lab, where 12 people performed different activities. Number 3 and 4 are from one volunteer house, and it is divided in 2 sets of data. Set 1 consists of 3 people. Set 2 is 2 weeks after the set 1 also consists of 3 people. Number 5, Motion Analysis Lab from Mahidol University. It consists of 20 elderly people performed different activities. Here are some examples of different types of datasets. Motion Analysis Lab, 20 people with 4 camera views. Movie Online Datasets, 90 people with 4 camera views. Volunteer House of 2 sets of data, which has 8 camera views. Artificial Intelligence Center Lab, 12 people with 8 camera views. Here are some samples of the datasets. The normal activities include sit, stand, walk, bend, clap, check time, phone call, point, and wave. Dataset sample images of unstable or fall activities. The unstable activities consist of collapse and movement, heart attack and fall, sleep and fall, hit obstacle and fall, dizziness and fall. Datasets 2, 3, and 4 contain 9 activities plus falls and unstable movement. Dataset 1 contains 9 activities without falls or unstable motion. Dataset 5 contains 5 activities including falls. People Detection Tracking and Recognition module. In this module, we capture a frame, and the system for detecting human utilizes OpenPose or TRT-Pose. The OpenPose network is a real-time system that is open source and performs a series of detection passes through multiple stages. When given an input image, OpenPose uses a VGG19 backbone that has been pre-trained on ImageNet to extract basic appearance features. After detecting the human, we adjust the bounding box to cover all the skeleton points inside the bounding box. We use deep sort to track the ROI for each subject from frame to frame. Recognition modules implement face detection and face alignment using MTCNN and FaceNet pre-trained network for extracting face embeddings for registered gallery images and probe images of family members in order to identify each family member in the scene. A sequence of these image patches is sent to the activity classifier and also the unstable movement prediction modules. These modules work to detect people from every camera viewpoint and keep track of any person in the video. Simultaneously, we accumulate a ROI for each detected and tracked person. Workflow of the activity classification module contains a cascaded hierarchical classifier for 9 ordinary activities and falls. Actions such as checking the time, talking on the phone, clapping, pointing, and waving may occur concurrently with sitting, standing, and walking, while they cannot co-occur with bending and falling. Hence, we can separate the major group of activities, sitting, standing, and walking, from the minor activities, check time, clap, phone call, point, and wave. The motivation for designing 2 different models is to differentiate 5 activities, namely clap, check time, phone call, point, and wave, from the others. The frame-wise cascade CNN for activity classification. There are 4 different models to classify 10 actions including fall. Action 1 includes one model which have 5 major classes as sit, stand, walk, bend, and fall, which is trained on 18 key points. Action 2 depends on 3 other models. All 3 models include 5 actions such as clap, check time, phone call, point, wave, and one major activity from sit, stand, or walk, trained on upper half 12 key points of the body. The Activity 1 model is composed of 5 convolutional layers. Each convolutional layer is followed by batch normalization and ReLU. The upper layer is a 5-unit fully connected linear layer with softmax activation. Training minimizes cross-entropy loss on 32 frame batches using the Adam optimizer with a learning rate of 0.001 for 480 iterations. Class sampling weights are used to balance training across classes. The three Activity 2 models have the same design as the Activity 1 model, except that they have 6 units in the output layer rather than 5. The detailed model parameters can be seen in the figure. The figure presents the architecture of the recurrent neural network model trained to predict unstable movement. We train the LSTM cells to capture temporal information across a sequence of frames. The input to the model is a 40-frame sequence consisting of 36 skeleton key points that encode movement. The training set contains consecutive frame sets with 35 overlapping frames. The 40 into 36 input layer is followed by a fully connected layer, 3 LSTM layers, then a final fully connected layer with 2 outputs, stable or unstable motion. To reduce overfitting and improve generalization, 40% dropout is applied to the output of the second LSTM layer, 50% dropout is applied to the output of the final LSTM layer, and L2 regularization is applied throughout the model. A batch size of 2000, learning rate of 0.0005, and cross entropy loss are used for training. In this section, I describe the notification service which sends real-time notification information to the caregivers. The Cloud API proxy is responsible for sending alert messages when a fall or an unstable movement is detected, including the incident type and uniform resource locator to access the image of the detected event. The system also sends an alert when the person is absent for an extended period of time. The notification service is implemented via a line notify API to enable ease of the use of accessibility via mobile phone or computer. The H-Cloud system includes the integration of modules for multi-person identification, cascading frame voice activity recognition, unstable movement prediction, and activity profiling. The web service can display activity summaries for individuals. The detection of absence of family members works as a background process. According to the activity profile of each person, if there is no new activity found during active periods of time, a detection of absence is recorded with snapshots from all registered cameras. The RESTful API is designed for transferring data from the edge computing device. The API consists of two main microservices: Activity Classification Service and Absence Detection Service. Experimental result of People Detection Tracking and Recognition module. In picture A, image sent to cloud for face recognition processing, where in B, the face is detected in picture A. Frame-wise cascade CNN activity classification model accuracy. It combined dataset 1 to 3, and we split them randomly into 70% for training, 10% for validation, and 20% for test. Here are the confusion metrics of all 4 models. To test the models, we used dataset 4, and here is the sample distribution. These are some of the sample images from the experimental result. These are the examples of fall detected by the model. The final test data from dataset 4 comprised 132 video files showcasing the 10 activities. Frame-wise classification tends to be noisy with occasional misclassification within a sequence. Image shows an example for a walking sequence in which an intermediate pose appears similar to a standing still pose. To increase accuracy of the frame-wise model, we simply aggregate each sequence of 40 frames and output the model's majority vote over the sequence. The accuracy of the model is 91.6. Stable unstable movement classification model accuracy. The table shows the dataset of 2 and 3's distribution. The stable unstable motion classifier achieves an accuracy of 79.26% with a recall of unstable motion of 97.02%. As a performance baseline, we trained a feed-forward neural network on the same data as the LSTM to obtain a frame-wise classifier. We considered each frame individually rather than the sequence of 40 frames used by the LSTM. We trained on a subset of the full dataset. The frame-wise classifier's test accuracy on the relatively easy dataset without occlusion or clutter was 65.82%. In contrast, the LSTM utilizing sequences of 40 frames obtained a test accuracy of 90.70%. This shows that the LSTM is able to utilize sequence information representing motion effectively. Here are some examples of stable and unstable motion detection. Our model sometimes has false detections of stable, unstable movement as shown above. Most of the actions that require bending of the body of a few seconds are mostly detected incorrectly. Most precisely, when the object, human carry, is heavier, the movement is similar to the unstable movement used to train the model. Therefore, such movements are classified as unstable by our model. Here is the examples of integrated system. This is the example of the web service displays activity summaries for individuals as well as camera views and period of absence. Here is a camera list of all installed cameras. Here is a section where activity analysis are done. This is the summary of activity. User can define an active period of time for absent detection. Here is the samples of alert system, fall detection, and unstable movement detection. The system has some limitations. The errors that do occur are mainly due to occlusion of one family member by another or by furniture. Another limitation is sensitivity to the conditions in which the models were trained. Accuracy will drop when the same models are moved to home with different lighting and environmental conditions. To address these issues, as with most deep learning models, there will be a period of fine-tuning to every new site until a sufficiently wide range of conditions is encountered and incorporated into the models. The next phase of research and development will need to focus on finding the right balance between the cost and benefit of the system to elderly people and their caregivers. Since the research described here began, NVIDIA released a new embedded system board, the Xavier NX, that is cheaper and more powerful than the Jetson TX2. We will explore the use of this system to reduce the cost and increase the effectiveness of the elder care system. One of the homes to deploy the elder care systems, as described here at scale with low cost to the end user, is a low bandwidth between the household and cloud providers. We hope to see that bandwidth bottlenecks will be eliminated through the introduction of low-cost 5G mobile access. A survey of the overall system's usability from a healthcare perspective by co-authors from Mahidol University indicate that as the system has been designed to be easy to use and secure as a monitoring system, it will be useful for future healthcare professionals to develop adaptations to enhance patients' mobility and functioning in conjunction with a remote physical therapy program. Goals achieved. We have designed and implemented a prototype IoT video monitoring device, a basic human detection tracking and recognition modules, fall detection and activity summarization modules, research early indicators of unstable movement that could lead to falls and other actions. We have also designed and implemented a framework for cloud storage and analysis of human behavior data. And lastly, we evaluated the system in a realistic usage scenario. During my PhD journey, I have some achievements. I have the paper published in Multimedia Tools and Applications, another paper in NBTC Journal,
अब ऐसा ना I think the
Okay,
autoplay.
so that was about the research that I have done. If you have any questions or comments on it, you can share with me.
Yeah, do write in the comments if you have any questions. Brilliant work. Thank you, Alif. Come on, guys, we're expecting questions because you can understand research paper. We know that. Do ask questions. Yeah, thank you. Thank you, Router. Yeah, we know, ma'am. Ma'am writes a great research paper.
Thank you very much, everybody.
Guys, any question? No. Ma'am, do give us tips on writing research paper if you want. Oh, there's a
Uh,
question by oh no tops. Can you share any thoughts on how the stream could be adapted to better fit the needs and customs of elderly people in person? Do you want to answer it, ma'am?
I think you can also answer it because it's about your group.
Well, we will think about it. On can you share a brief description of the
Okay,
data
about the
processing?
data pre-processing. Thank you, Ali, for your question.
On exchanging his topic perspective upon it. Ma'am, do you want to answer the
Can you
question
can you
given
hear
by
me?
Alif? Yes, ma'am, we can hear you. He needed a brief description of data preprocessing. Alif. And yes, ma'am, we can hear you. If you like to add any words to the question.
Okay, your video was stuck. Okay, I can hear
Oh,
you. All right,
I
so
think internet issue.
okay, no problem. So answering to honor no, I would like to say that this system could also be adapted in Bangladesh because there are many old homes and many hospitals where elderly people stay, and many of the cases they don't have caregivers. In that case, if we could implement this kind of systems in the hospitals or the old homes, I think it will work in that cases. And for Alif Khan's answer, for the data pre-processing, what we did, we captured the videos from the CC camera for all 8 cameras and have the 360-degree views of all the environment in the room. And then what we did, when we when we detected the human in a video, we cropped the person from the video and then processed on that ROI to get the face and also the whole body image from the video. This is how we processed. And if you talk about the training process, when we captured the video from the CC cameras, we have made the short clips of all the activities and then trained our model to know the 9 ordinary activities: fall and unstable motions.
Thank you, ma'am, for that question answer. Any more questions? Does BRAC you have any club related to AIML?
That's a good question.
I don't answer that.
I think we should start real soon.
Yeah, we hope so. Also, I think BRAC University Computers Club are doing works with AML. So yeah.
Yeah,
Also,
computer
Robotics
club.
Club are doing works some.
Right. They're working with all the areas.
Yes. Any more question? Also, ma'am, can you give us tips like what are the important things should we look at when working with researchers?
Right. To come up with the first step, I should say that one should have their passion of work to improve or observed problem. What we do in daily life, like we observe so many problems that we want to solve, right? So if you encounter that kind of thing and you try to solve it, so pick that kind of problem from the environment, and that could help socially and also academically. So what happens is when you have already have a topic or idea that you want to work on, just search that if any other people have worked on it or not. How do we search it? We search it in Google Scholar or scientific journals sites, Elsevier, Springer. We can go to their site and search all of these papers related to the same topic that we want to work on. And once you get all the topics, you read like 15 to 20 papers at the beginning, I would say. Like whenever you're free, you just read like a story paper. So once you get a paper, you read the abstract, introduction, and then conclusion first to get the idea what you are thinking is matching with the paper or not. So in a research paper, there are mostly five sections: abstract, and then starting with abstract, we have like introduction, literature review, methodology. Then we have results section and the conclusion and discussion. So if you have this kind of sections, go to the abstract, introduction and conclusion, read it, try to match with the idea that you have generated in your head. And if it matches, a very good paper. It only takes one paper to start working on it. Once you get the first paper, you learn the idea how they did it, and to find more related paper, go to their references and literature review. So once you go there from the references, this is a very good trick to find the more important and the related works. So go to their references, read some references, and once you get more in papers, go to their references and so on. So hop into references, go deeper to get the related papers, and then you start ideation, like how can you match all the papers that you liked and come up with a new idea. This is like a quick tips.
I think you can search to Sky have like research papers like read from download PDF from that free PDF. I think they publish free. What the I forgot the website name. Like they publish free PDF of the research papers, so you
Yeah,
guys
some of the
can
sites
check
there.
websites.
Yeah, yeah.
So there's a question from Kaji Iftikharul Adnan. So is it possible to implement multi-layered neural network to better match the video frames in order to increase the accuracy of the model? Uh, not.
Yes, we can use that. We can have multi-layer neural network to do that. But in these cases, the research that I have done, we just use the video frames and extract the frames worked on the images. Actually, video is just a sequence of frames, right? So we actually focused on the not the entire image. We cropped out the person and then worked on the key points situated on the image. So actually this is a lightweight model already. So if you talk about the CNN models that works with the pixels and all the image, that is a kind of a heavy model. So that's why we chose the key points to make it a lightweight.
Another question by Rosa. Can you elaborate on the specific challenges faced during the development and testing phases of the prototype system?
Of course, that was very challenging because we have to deploy this in a real scene, which is two elderly people's house, and then we deployed. We set up all the cameras and all the systems, and it was a real time video feeding and trying to get the notification. Still, I get the notification that we deployed for the houses, so it's still in the mobile phones. So the challenges are like people do many kind of activities all day, right? So we cannot just concentrate on only nine ordinary data that or activities that I talked about here. We have to have many activities that can lead to challenge, like that I said, like in my research we had some challenges whenever people are working and with the heavy things on their hand, they work like this and they walk like they are having a trouble in their feet. This already looks like an unstable movement when you're trying to lift some heavy things. So that was the challenge of unstable and the daily motion activity. So I think, yes, we need to improve these systems with more newly diverse models that are coming into the field.
Yeah, thank you, ma'am, for the answer. So, Nasim, Anjum promise. How did you ensure diversity in the training data?
Oh, trust me, we have so much of data. I already talked about like five data sets. All out of five, we have created four data sets. It took like 6 months to get all the diverse data from different sectors and also simulate the data of falling and unstable motion detection. So we made ensure that it should have all the diversity in the training data.
Thank you, ma'am. Take notes, everyone. This answer valuable. How can I prepare myself to write an well-detailed paper? By Mehrin Malik.
Oh, that's a nice question, Mehreen. I would say,
Great.
yeah, I would say you start with your your a topic that you're very interested in, and if you want to have a well detailed paper, the tips and tricks should be it should focus on visualization. So if you have all data and all the numbers, try to make it more pictorial view so that people will be more interested and learn from the pictures that you share with the data. Maybe bar charts, pie charts, and all the tables, figures that make your system more look more detailed.
Yes. Then next question we have Devjyoti Mitra Bhega. What ethical considerations were taken into account during the development of this system, particularly regarding privacy and data security?
Very nice question. Since it's a PhD work, and we worked with the real elderly people, not like mimicking. So we went to the Mahidol University, and there was this physical therapy department where 20 elderly people came to perform the daily activities. They had a history of fall and not fall. Like some of the people, people from the elderly group of 20 people, where they fell before they had a history of fall. They already fell down before, and some of them were very old, never fell down. So what happens is we actually circulated that we want to create a data set, and they came with their wheel, and then they had to sign a consent paper that they are willing to share their data and they are willing to perform in this research. So we have this ethical documentation to do that. And also, when we tested our system, we deployed in two elderly people's home. We also took their permission to have their privacy on, and we didn't set up the system in the bedroom or any privacy mattered area. We set it up in a lobby or where they always work, like they cook or clean, this kind of places.
So take consent, everyone, before taking any data for research.
Of course, yeah, that's a very important thing. if you're working with the human analytics.
Yes. So, Ononno, again, what inspired the development of this video analytics system for elder care? I'm interested in it because I have real life experience with it regarding my grandparents, which inspired me a lot in it.
Perfect, Ananda. That's what we start research on. You need to you have this real time, real life experience. That's why you're already passionate about this research to work on it, right? So I also had this kind of passion, which inspired me to do this kind of thing. The first thing that I started working with the research was with the blind people, blind assistance system. From there I started with the human analytics, and it ended up like I want to help the social, uh, so I want to help socially and the people around us. So that's why it inspired me to work with the elderly people. Mostly we see, like, when our grandparents get old, there are very less people around them to take care of, right? So when, because we have to go out for work and we come back very late, and in between we have to take care, we cannot just look into the CC camera all the time. So if we have a notification that can lead to like absent detection or fall or unstable, we can just quickly check the CC camera. So that inspired me.
Yeah, so brainstorm everyone. Brainstorming these ideas helps us your research paper more. So is there any possibility that your dataset will be publicly available for further contributions?
Of course, yes. I'm currently collaborating with my own university, AIT. So I have to, again, it's about the data privacy, right? I have to sign a consent that I will be working with only research, not commercially. Then I can make it public. So I'm already working on it. And if any of you are interested to write a research paper on data set, like, just the data set can be also a part of research. How did you create from the scratch to the end? So I am really thinking of making it public for the uh, later research, and also have a very good paper on how did we create this data set, because this is very unique data set.
Yes, indeed. So any more questions? I can see none.
There are a lot of questions I see.
So there are lots of research paper on machine learning, I guess, in the internet. So I think we have to think and brainstorm more because we have to search for unique ideas.
Yes.
Oh, another question by Iftikharul Adnan. Can you please elaborate the computational complexities you had to encounter while working on data models?
For this, I have tried empirical analysis. There were many models I have created, not only one, like, because it was the data was complex when I worked with the video frames, and every frame was extracted to recognize the activity from. So I had to work on different kind of models to come up with the one which is actually giving the result. Then I found out that only frame-wise cascaded model is not enough for activity classification. Then also we had these parallel two models of LSTM and frame-wise. Both the both the models actually runs together, and we have the majority vote of both models to take the answers, like if actually there is a fall or unstable movement detected. So this was very complex. When I came with the models, I had like uncountable models trained on it to come up with a better result. And thus, I also mentioned in the research that we aggregated frames, 40 frames, to have a majority vote as well. So I actually verified in certain labels to tell it like if it is a fall or not, because there are many activities. Humans are unpredictable. There are many kind of activities that can lead to a fall, that can seem like a fall but not fall.
Especially dealing with Bangladesh.
There are many. so many activities. You cannot, unpredictable. Even if you want to sit, I had this challenge in the data set, mainly in the Asian countries. What happens is we tend to sit on the ground and enjoy tea or just sleep like that, right? So what happens is lying on the floor also detects as a fall. So that's a very challenging thing at this moment. I'm trying to figure out and brainstorm like what I can do.
Yes, South Asian problems.
Yeah, that's the culture. The culture. Thank you, Iftikharul.
Thank you, Jabarul. And another question by Murtasim Khan Jami. Could you please tell me about explainable AI? What is the future? Uh,
Okay, that's a different topic than the one that I'm sharing here. But I can tell you a little bit about explainable AI. It's about the model, how the model actually working. What we do, we don't used to know a model was like a black box. We had to add layers and we worked with the neurons, but we could not calculate in depth like what are the calculations or complexity going on. This explainable AI actually can interpret the model, like how is it working. It can be in the any kind of research, could be in image processing or could be in natural language processing, anything. If I talk about the image processing that are in my field, in a picture, if I want to relate this one, the research I just shared, in here you saw that I worked with the skeleton key points, right? So if if the model I want to use it with the XAI, what happens is it can show me that I don't need the whole body. Maybe I need only few of the skeleton points that can also lead to the same model accuracy. So I think XAI is trending now, and if you can use it, we can have very light models. And I have this plan. I have many, many plans with this research to use in different sectors to see if we can improve the model. So XAI is also one of the thing in my mind to work on.
so
I hope
if you
that
guys want to work,
I hope
yeah,
that
man.
answers Jami's and question.
If you guys have any plan, do ask. We will help you. Like any research plan, but
Yeah,
don't talk about secret. Don't share your secret research names like topic. Just
no, it's all right. We can collaborate and learn from each other. And
yes,
I really like to train the second year students for to do research. I train from the scratch, like how to search, how to uh, brainstorm, how to come up with some ideation. It's okay if you don't know AI ML. We can go step by step.
yes, you have to be consistent. So yeah,
Yeah,
we
yeah,
can take an inactive members.
yes, of course.
So there's any more question, guys? I see none. I guess no one have any other question. I think so, guys. Ma'am is also our research supervisor. So if you guys also want to work, you have to be a second year university student and then be an AI enthusiast. So AI and machine learning.
Also to also please have a background of data structure and algorithm so that I know you at least can code.
Yes. Yes.
Right.
Without that, you can join.
Yes. No, we can do that, but that is a plus point if you have AI
Yes.
and ML courses. There are many courses in YouTube and other resources. We can just
Also,
go.
you don't have to wait for thesis. Like many of you have wait for thesis, then start research. That's
Yeah, yeah, that's a very good point. Yeah, you don't have to wait for a thesis time. You can start right away.
so. Do you guys need any research tips? Like you guys want to start research? no one have any question like great
Thank you
session.
for that. Thank you.
Oh, another question. I think it's from Tanvir Rifat. Is TensorFlow.js stable, or should I switch to using TensorFlow with Python, or it's a trade-off?
I have used TensorFlow with Python. I think that works well.
So I guess that's it. I think
Answered a lot of questions though.
yes, but you answered them cleverly. That's great.
Thank you. But it's a very, very nice session. I really liked it, and I'm open
We
to
really
work.
learned a lot from you. Like this is start of this session, and we had you at our first session. So there will be more sessions in the future. So we hope that we will bring lots of guests, and also again you will have you again. So thank you, ma'am, for being with us, supporting us. It's mean a
Thank you
lot
so
to
much.
us.
Thank you. You're
Oh,
doing
there's a question.
again.
Muhtasim Khan Jamil, yeah, lots of curious students. Is
Okay. Is there any opportunity to
mm,
work with ma'am on XAI? Yes, of
oh,
course. You're welcome. You're most welcome. Please do come.
to share your expertise, then we will think about you.
Sure, Jami. You're always welcome.
Yeah,
You get connected with LinkedIn, or you get my email address in the
yes.
BRAC website also. Yes.
Yeah, do write a proper email, then send it to mail with your expertise. Then ma'am will think about you.
So
Thank
that's
you
it.
for amazing session.
Thank you, Joannu, for making this happen. I really liked it, and I'm
Yes.
open to work with all.
Also, yes.
Okay.
Also, before you leave, we want to share an announcement with us. Like, we will be starting an machine learning writing club also, where we will read machine learning papers. Then we will work on it. Then we will write a paper that publish them on Google. So make sure to watch the latest session on our Facebook page, which is ML Reading Club and Writing Club. I will share you guys the link of the club. So make sure to join, like their page, and also join our meetup group of 700 plus people. So we want to increase more members. So make sure to join the group so that we can be at the toppest group in the TensorFlow user group. Also, take session, guys. Like we want everyone to take their sessions and learn. It will help you guys a lot in the future. Also, you will gain swags from Google. So yeah, that's plus point. So make sure to take sessions. Also, you can watch our previous posts like on TensorFlow user group page, Bangladesh page. There are tips on how you can start your session. So make sure to check the posts. And there are lots of thank you, man.
Thank you very much.
Yeah. Also, thank you everyone for asking lots of questions. Like we're really glad that you guys are interested in our research, and there will be lots of session. It will be taken by you guys. So make sure to watch. Make sure to fill up the pre-event form so that we can help you guys take your sessions. So let's end the meeting. I guess no one have any questions, so we can end it now. Thank you everyone for joining.
Thank
Take
you so
care
much.
and good night.
Bye
Bye
bye.
bye. It's